get going. Okay, so question 1, we're going to do this table purely because it is easy to lose marks. If you lose or if you miss one of these blocks, then you lose a mark. You guys get what I mean? So we're going to do this one. Okay, let's look at number 1. The first tip I have for a question like this is to first simplify where you can before you start ticking those blocks. Are we with me? Now let's look at number 1. That's negative pi squared. Let's just talk about pi on its own. Pi on its own, we know, is a irrational number, right? So if you square an irrational number, you're making it worse. All those decimals will just be even longer, and there's a lot going on. So what do you think pi is? So I'm going to ask, do you think it's a whole number? Negative pi squared, is it a whole number? No, it's not. Thank you for responding, guys. What about natural number? An integer? A rational number? An irrational number? Yes, so this is indeed irrational. Now, I'm going to give you guys a heads up. Okay, a lot of learners, as soon as we see this negative sign here, we immediately think it's an integer. Now, integers does include negative numbers, but it's negative whole numbers. So negative 1,5 is not an integer just because it's negative. Are we with me? So be very careful in a test. When you see a negative, you immediately assume it's an integer because that is incorrect. Okay, integers are negative, yes, I agree, but they are negative whole numbers. Okay, let's look at number 2. Okay, is number 2 whole number? No, it's not. Is it a natural number? No, it's not. Is it an integer? Nope. Is it a rational number? Nope. What about an irrational number? Yes, this is also irrational. Okay, let's look at number 3. We have a negative 21. Simple number. Is it a whole number? Is negative 21 whole? Okay, we have someone who said yes. Remember, whole numbers only includes the positive numbers. So it's 0 and all the positive numbers. So it's definitely not a whole number, right? Is it a natural number? Hello, Shady, welcome. Would you say it is a natural number, negative 21? What happened to the responses? Not one person is responding. Is negative 21 natural? Is it because we're not sure? Okay, no, it's not a natural number. Is it an integer? Yes, this is our first integer that we're dealing with. It's negative and it's whole. Okay, there are no decimals, there are no other fractions. It's a full whole number that is negative, so it's definitely an integer. Is it rational? It's okay, Le'acho, that's why we're doing this. So in a test, you wouldn't get that wrong, right? Is it rational? What do you guys think? It is indeed a rational number. And if it's rational, can it be irrational? If we know that it's rational, then it can't be irrational. Are we with me? Okay, so that's it. We're done with negative 21. Now, number 4 speaks to what I spoke about simplifying when you can. Okay, we can't possibly make a decision about number 4 as it is unless we do some sort of working out. Do you guys agree with me? It's just it's a sum basically. So we cannot just guess and decide whether it's rational, irrational, whatever. So on the side of your paper, you would have to do some sort of working out. My handwriting looks horrible. I look like I'm writing with my foot. This is the cube root of negative 8 over 4. Okay, let's look. The square root of 6. So is 6 a perfect square? Is the number 6 a perfect square? You're right, Tado, it's not. Because if you square root 6, you're not going to get a whole number. So it is not a perfect square. So I'm going to leave this guy here for now. Okay, minus the cube root of negative 8. How much is the cube root of negative 8? The cube root of negative 8. Thank you very much. That will be negative 2. And this is all divided by 4. Okay, then you have the square root of 6 plus 2 divided by 4. Okay, let's stop here for a second, right? We know that square root of 6 is irrational. Are you with me? Because it is not a perfect square. So if you take that irrational number and you add something to it and you divide by 4, is it suddenly going to make it rational? No. So we can, in fact, classify it from here. What would you say about this number? Hello, Umar. How are you? There we go. Brilliant. You can say that this will, in fact, be irrational. Okay, do you see what I meant, guys? You don't have to work the whole thing out, but you can make educated guesses. If I take an irrational number, add stuff to it, divide it by 4, I'm just making it worse, isn't it? So it's just an irrational number. Now let's look at number 5 and pretend you don't have a calculator, right? You can't possibly go multiplying 9 by itself 11 times. That would take forever. Do you guys agree with me? That would literally take so long. So how would you tackle number 5? Okay, first of all, we have a negative base. We see that. And we also have an odd exponent. Okay, so let's talk about this. When you have a negative base and an odd exponent, will your answer be negative or positive? There we go. So it's going to be negative. And will this be an irrational number? No, because you're multiplying a whole number by itself over and over and over. So you know that you're not going to have any decimals, but you also know that this will be a negative answer. So let us fill this in. Okay, will it be a whole number after the deductions that we've made? Will it be a whole number? No. What about a natural number? No. Will it be an integer? Yes, it will be an integer. Where am I? There. And if it's an integer, is it rational? Yes, again. And if it's rational, can it be irrational? No. So we are, in fact, done with this one. And the mark allocation for this one is actually quite easy. If you have the whole row correct, you get your 1 mark. Which means if you ticked a wrong block here, that's considered as not correct. So you would lose the mark for that entire row. But also if you leave out one tick in a row that's supposed to be there, you lose the mark for the entire row. Okay, can we move on, guys? Can we get a thumbs up, thumbs down? No questions, anything? Wonderful. Wonderful, wonderful. Okay, now people were not in yet when I said the way this works is you guys are going to get to choose which questions to do. We do not have enough time to do all of the questions. So I'm going to give you a choice between B and C. Whatever we don't do, you're going to get the question paper with the memo. Okay. What if you take every block? Then you're going to get it wrong. That will be incorrect. Okay, so this is B and that's C. So let's take a vote between B and C. Only a couple of seconds. Thumbs up for B, thumbs down for C. I think that's going to be the quickest way to do this. Okay, no, that was a terrible way to do this because now they're all just mixed. You need to press once, guys. Otherwise, you're tipping the scales. So let me rather say in the chat, please type C or B. Remember, I only answer once. Okay. So far, we have 1, 2, 3, 4 C's and 2 B's. 3 B's. Okay, it seems C is winning, but it also seems not everybody is answering. Okay, we need to all participate, guys. I know there are now 11 of us in here, so I expect 11 answers, and so far I only have 1, 2, 3, 4, 5, 6, 7 answers, which means 4 people did not respond. Okay, but I'm going to move on. We have more C's than we do B's, so let us look at C. C says subtract, so you know you're using subtraction. Hello, Carmen. Welcome, welcome. So we are subtracting this expression from the sum of these two expressions. Okay, so we know we're subtracting and we're adding. Now, the one that comes after the word from is the one that goes in front. Are we with me? So we first add. So you first say yx squared minus y plus 6 plus, okay, I'm going to put this in brackets. That's a good habit to have, to put it in brackets. So from the sum, we are subtracting 2y plus x squared y. Okay, before I continue, does this make sense to everyone? Subtract from. The one that goes after the word from is always the one you start with because that's the one you're taking away from. So it has to go in front. Okay. Great. Now that we've sorted that out, let's simplify. I'm going to write this as x squared y because it looks weird. Minus y. Will this plus affect anything in the bracket? Will the positive outside the bracket affect any of my numbers or signs inside the bracket? Will it? Look carefully, guys, okay? Look carefully. It won't, guys. It really won't because positive times a positive, it remains positive 6, isn't it? Remember the plus says keep. Remember when we did the keep and change? That positive is telling us to keep the signs inside the bracket. So it's not going to change any of them. So my 6 will remain positive. Again, positive or positive. My 3x squared y will remain positive. And a positive and a negative gives you a negative y. So none of the signs in the brackets have changed. However, will this negative change the signs inside my bracket? Yes, it will. Okay, that's why I put brackets around it. So this negative, when you times it in, will make my 2y negative 2y. And it will make my x squared y also negative x squared y. Okay, now let's look for like terms. I have a x squared y plus 3x squared y minus another x squared y. My other like terms are y and minus 2y. And then 6 is on its own. Let us start with, let me write equals here. I have a very bad habit of not writing equals, and it just looks like a bunch of stuff. Let's look at the x squared y's. Okay, what's x squared y plus 3x squared y minus x squared y? What will that give us? What will we end up with? X squared y plus 3x squared y minus x squared y. There we go, guys. That would be 3x squared y. Because that's like saying 1 plus 3, which is 4, minus 1, and you're back to 3. Okay, let's look at the y's. I have a negative y minus another y minus another 2 y's. And that gives us, thank you very much, minus 4 y. And then I have a 6 that is all on its own, so I'm just going to rewrite it as plus 6. Okay, let's look at mark allocation. This is out of 4 marks. Firstly, setting up the equation in the correct manner is worth 1 mark. Properly distributing your negative and the positive, those are each out of 1 mark. And then, of course, your final answer will be out of 1 mark. Can we get a thumbs up, thumbs down for this one? Remember, if you have questions, just stop me. That's why we're here. Okay. Can we move on to question 2? Screenshots, are we done? Remember, we are going to get this paper with the memo, the full paper with the full memo, because we're skipping questions. Okay. Now, for number 2, I am deciding we're definitely going to do B. And I'll tell you why just now. So you guys need to vote between A, C, D, and E. Okay, I'm going to show you again. A, this is A, C, a D, and the E. Okay. I said we're already doing B le'aho, so you can't vote for B. It's between E, D, C, and A. Okay, E. A lot of people are voting for E. Ma'am, how much is the paper out of? I actually can't remember. I think 75, but I'll confirm for you, okay? I'll confirm it for you. Is everybody voting E? It seems like everyone is voting E. Remember, we vote once, guys, because I have to count it. So you can't vote double because you are confusing me if you vote double. Okay, we have 1 for D. 1, 2, 3, 4, 5 for E. Okay, so E wins. But let's start with B first because I have to do this one because I see a lot of mistakes. Okay, how do we do B? Let me ask you guys. How are we going to do B? You expand the brackets first. Okay, how? There we go. Now, guys, the amount of times I have seen learners distribute this exponent kills me because then you miss the mark for the middle term. Are you with me? You cannot distribute the 2. Why not? Why can't you distribute that exponent? It's not different signs. It's the same bracket twice, isn't it? So you write it out. This means x minus 4. I don't know what's happening with my handwriting. X minus 4 times another x minus 4. That's what squared means, right? Why can't you distribute that 2, though? I need to see that you guys know why you cannot distribute the 2. Come, guys. Anyone? Yes, you can use that one as well. No, you can't distribute it because we have a minus, remember? The only time we distribute that exponent is if there's a times or divide inside my bracket. Remember the law of exponents number 4. So if I had 4x, like so, with a squared outside, then I can distribute because it's multiplication in there. But as soon as you have a plus and a minus, no distributing of my exponent, please, guys. I am begging you. Okay, I have seen it happen way too often, and it makes me want to cry. So please don't do it. Okay, let's FOIL. Umar is ahead of us. first and outer. That would give us x times x, and x times x, as Umar has told us, I'm going to take your answer, is x squared. Our outer is minus 4x. Our inner is negative 4 times x, so that's another minus 4x. And my last is negative 4 times negative 4, which is positive 16. Okay, then, thank you guys, we add our like terms that are in the middle, and that's x squared minus 8x plus 16. Now, the mark allocation for this is a mark per term. So a mark for your x squared, negative 8x, and your 16. Can we get a thumbs up, thumbs down on this question? If you have a question, it's a good idea to ask it when I ask for the thumbs up, thumbs down before we move on. Okay, so always remember, distributing exponents is only for when you are timesing and dividing. Don't do it if there's a plus or minus in the brackets, please. Okay, let's move on to the next one you guys chose, which is E. I'm guessing it's because you saw fractions and you're like, oh my goodness. Okay, but you can do this, guys. You can do this. In this case, we have to FOIL, isn't it? We have to FOIL. We have two brackets that are being multiplied. So we're going to do the first, outer, inner, and last. Let's look at the first. A half x times another half x. It's definitely not 1. Let's talk about multiplying our fractions, excuse me. Multiplying fractions. When you multiply fractions, how do you multiply fractions, guys? If it was just a half times a half, how would you do that? A half multiplied by a half. How would you do that, guys? Do you remember how to multiply fractions? It's actually the easiest thing you can do in fractions. Yes, you multiply the numerator with the numerator, which means 1 times 1. And you multiply the denominator with the denominator. So 2 times 2 is 4. Okay, so your first term will be a quarter, and x times x is x squared. Do you see it wasn't that bad, guys? So you just use the knowledge that you have, and you'll definitely find the right answers. Okay, let's look at outer. Now I have, okay, firstly, I'm multiplying a positive and a negative. So what is my answer going to be? A positive and a negative will give me a negative answer. And then I have a half x times b. Can I simplify this any further? No, because we don't know what x is and we don't know what b is. So it's literally a half x times b. And then our inner term, this time it's a positive and a positive. And it's also a half x times b. Isn't it? Because it's a half x times b. Okay, and our last term is probably the easiest. A b times a negative b. How much, what does that give us? B times negative b. Is it positive or negative? There we go. Minus b squared. Let's deal with our like terms in the middle. What's negative a half xb plus a half xb? Negative a half xb. It's 0. So what happens to those middle terms? They vanish, right? It's 0. It's gone. So then you're left with? Nope. I've been saying a half so many times. You're left with a quarter x squared minus b squared. Let's look at mark allocation for this one. You're going to get a mark for correctly foiling and a mark for your two terms at the end. Can we get a thumbs up, thumbs down on this one? Okay, screenshotters, have we done our thing? Are we satisfied? Okay. Wonderful, wonderful, guys. Now, Okay, let's do the vote first. Let's look at A, B, C, D, and E. And F. Oh, geez. Okay, no. Let's first choose between A, B, and C. A, B, and C. This time we are factorizing. This time we are factorizing. A, B, C. So far, B seems to be winning. 1, 2, 3, 4, 5, 6. I have 7 votes out of 11 people. Can we have everyone vote, please? Thank you. B won, but people aren't voting, which makes me think we are not all listening, but it's fine. Okay, what are the methods of factorization that you guys know? Just list them for me in the chat. Okay, Umar's getting us started. Common, I don't know what common you're talking about. There are 2 commons. Okay, common factor, 100%. Difference of 2 squares. You have your trinomial. You have grouping. Common factor can also be common what? A common factor can also be a common bracket. Okay, so the common factor can also be a common bracket. Now let us look here. We have 2 terms. Are you guys with me? Are you guys in agreement with me that we have 2 terms in B? Okay, so let's look at our 2 terms. It's definitely not grouping because there's only 2 terms. Everyone agree with me? It cannot be a trinomial because there aren't 3 terms. Okay? It is not difference of 2 squares because we don't have 2 squares there, and it's definitely not a difference, it's a sum. So we're left with common factor or bracket. Which one of those do you think it is? And I see some of you guys already knew what to do in the chat. Tando and Entle, I see that you already knew what to do. It's a common bracket, but is it quite common right now? It has the same terms, but there's something different about it, which is what? The signs are wrong. Thank you. Okay, so I'm going to rearrange the second brackets to show you that the signs are wrong. So x squared, no, I'm going to write in green. X squared, we're going to leave it as 2x minus 1. Plus, I'm going to change this to start with the 2x and end with the 1. See, if I write them that way, you can see that they're the same terms. It's just that in this bracket, my 2x is negative, whereas it's positive here. And in this bracket, my 1 is negative, whereas it's positive there. How do we fix that? How do we fix the wrong signs in my brackets? I change my sign in the middle, which means I'm removing a negative 1. Is everyone with me? I'm taking out a factor of negative 1. So from my second bracket, if I'm taking out a factor of negative 1, now you don't have to write everything I'm going to write now, but I'm going to write it anyway so that someone who's confused will understand what I'm doing, okay? I'm taking out negative 1 from this bracket. Okay, and taking out, which is the opposite of multiplying in, means you're going to divide all of the terms in the bracket by whatever you took out. Does that make sense to everyone, guys? If you take out a factor, you then divide everybody there by that factor. Okay, so if I divide negative 2x by negative 1, what's left in my bracket? Dividing negative 2x by negative 1, what's left in the bracket? A positive 2x, beautiful. And if I divide positive 1 by a negative 1, what's left? There we go, negative 1. Okay, does this make sense to everyone, guys? I need you guys to understand what we did just now here. Thumbs up, thumbs down on the taking out of a negative. Okay, Shady, you're honest. Okay, Shady, let me try and show you something. If we had something like 2x plus 4, what would my common factor be between 2x plus 4? It would be a 2, 100%, right? Now, what's left in my bracket after I take out a 2? What's left for my second term? Just the x. And what's my first term, sorry, and what's left for my second one? A 2. Now, how did we decide that an x and a 2 was left? What did we do to those terms to decide that an x and a 2 was left? We divided. So that's exactly what I did over here. I decided I don't like the signs of these terms, right? So I need to take out a factor that will change the signs but not the value. So I can't take out a 2 because it would just mess up my bracket, wouldn't it? But I can take out a negative 1 because if you divide anything by 1, does it change the number? It doesn't change the number, but it can change the sign. So I am taking out a factor of negative 1, which means I'm dividing both of my terms by that negative 1. That's why my first term changed from a negative to a positive, and my second term changed from a positive to a negative. Would it make a difference if we hadn't swapped the terms? Yes. No, it wouldn't. It actually wouldn't. The reason I swapped them, brilliant. Sometimes the original order, the one that was in the question, sometimes it's hard to see that both signs are different. Do you see what I mean? Because I've seen something like, let's say we had 2x minus 1 and 1 plus 2x. Okay, do you see those brackets? They're in the messed up order. I'm going to swap them around. In that case, would taking out a negative help us? If I took out a negative from the second bracket, would it help us? No, it wouldn't, because it would make both of them negative. Do you see what I mean? But it's hard to see when the order is messed up. Do you understand why I did it? Brilliant. So I always put them in the same order. So I put the 2x first, I put the 1 next. Well, if there was something after that, I would put it after that. Just to see if removing a negative 1 will solve my problem, or if this isn't a common bracket at all. Because it's possible you can get that, in which case you would first have to multiply it out. I've actually seen that happening. So you would first have to distribute, and then it turns into a trinomial. Okay, I hope my logic makes sense to you. Brilliant. And you're very welcome, Shady. The whole taking out a negative 1 thing is very controversial. Like, a lot of people don't get it, but I'm glad you're good. Okay, guys, happy? Now we've taken out our negative 1. And what is this negative 1 going to do with this positive that's over here? The other methods, that's true. But if you don't swap them around, sometimes you take out a negative and then you mess it up. Like something goes wrong. Okay, it makes it a negative. So x squared 2x minus 1 minus 2x minus 1. Great. Now do we have a common bracket? Now do we have a common bracket? Yes, we do. We indeed do. And our common bracket is 2x minus 1. Tell me, what's left in my first term after I take out my common bracket? X squared. And what's left in my second term? Okay, if there's no coefficient here, guys, there's an invisible 1. Do you remember that? If there's no coefficient, there's an invisible. It's actually the negative 1 we even took out in the previous step. So there's a negative 1. So what's left is minus 1. Are we done with this one? Are you sure? Look carefully. Look at the list of factorizing that you have on the side. What can you still do to factorize this thing? Difference of two squares. Look at my second bracket, guys. I have a difference and I have two square numbers. Do we see? So the first one I can't do anything about. There's no common factor. There's nothing we can do. But this I can. So I'm going to open my two brackets. Okay, and I'm going to ask you guys what goes in my two brackets if this is difference of two squares. Okay, I have a plus and a minus. What else? An x and a x. And finally, a 1 and a 1. And now are we done? Yes, we are, guys. Now, this thing should have actually been worth more than just 2 marks. They definitely ripped you off here. Okay, I would definitely give a mark for change of signs, and then a mark for correctly placing your factors, and another mark for seeing your difference of two squares. Can we get a thumbs up, thumbs down on this whole question? Beautiful. We're going to do one more and then we're going to take a break because we are, in fact, halfway almost in our lesson. Can you believe it's already been almost 45 minutes? Yes, Avril, your hand went up. Oh, okay. As long as you don't have a question, it's good. Okay, let's do one more. So we chose between A, B, C. Let's choose between D. So there's D. Here is E. And there is F. So F, E, and D. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Again, 7 people have voted. D, E, and F. So this is D, that's E, this is F. Okay. The ones we skip, if we have time at the end, I'm going to come back to them, okay? We're going to utilize all our time. Umar always wants the controversial ones that nobody votes for. He's like, come on, guys, vote for D. Let me see, what does D look like? Oh. Okay, Umar, I'm just going to give you a clue. I know you can do it. Okay, I know you can do it. You take out a common factor of negative 2. Then it's just a trinomial. You'll be left with x squared minus 9x plus 8. Okay, and then you just do a trinomial. Happy? F is actually very similar to D. It's just that your common factor is your common brackets. So it's a similar thing, but in this case, it's a common bracket. Now let's look. We have a problem here, right? What is our problem with the brackets? You see the first term has an x plus 4. The last term has an x plus 4. But there's a problem with the second bracket, which is what? My second bracket, what's wrong with it? It's not x plus 4. Do you see it? It's 2x plus 8. So is it the same as the other guys? There we go, Tando. We can factorize it, isn't it? My second bracket has a common factor. What's the common factor in my second bracket? It's 2. So let me rewrite the first part because we're doing nothing with it currently. Jeez. X squared, x plus 4, plus 2x. And I'm taking out a factor of 2 from the bracket. Okay, what's left in my bracket? After you take out a 2, what's going to be left inside your bracket? A x, yes, and plus 4. Beautiful. And then minus 12, x plus 4. Now, do we have a common bracket? Now, do we have a common bracket? Yes, and it is x plus 4. So let's take it out. So we're removing x plus 4 from all three terms. Let's look at term 1. What's left in term 1 after you take out x plus 4? X squared. Beautiful. What's left in term 2 after you take out x plus 4? Look at the beginning, guys. We have a 2x, but we also have a 2 that we removed, isn't it? There we go. 4x. Nice, guys. And what's left in my last term? Negative 12. Okay, before I continue, does this make sense to everyone so far? Specifically that 4x, does everyone see where it came from? Okay, let's look carefully. We already had a 2x in front of my bracket. Do you guys agree? There was already a 2x in front of the bracket. Now, we wanted this bracket to look like the others, so we removed an additional 2 from the bracket. Right? And that 2 allowed us to end up with the bracket that we wanted, which is x plus 4. So these two guys are now in front, and they're being multiplied by one another. So y said 2x times 2, which is where the 4x comes from. Are we happy, guys? Is it feeling a little bit better? Entle? Okay, there we go. So we just multiplied the two factors that were in front. Okay, are we done with factorizing this thing? No, because we can still do what? We can still do the trinomial, isn't it? Yes, and clear the trinomial. Okay, my first bracket I can't do anything with. It's not a difference of two squares. There's no common factor. So I'm just going to rewrite it as it is, x plus 4. Now, when we factorize a trinomial, we know we're going to end up with our two brackets. So I'm going to open them up. What's my first factor in both of these brackets? X. Okay, what's the sign for my first bracket? A positive. Beautiful. Does it mean we're keeping or we're changing the other guy? Does it mean we're keeping or changing? Everyone says change. So if it's positive, if this is a plus, it's saying we're changing this one. Is that what you guys are saying? We forgot our factorization. A positive means keep, remember? Because when you multiply anything by a positive, it stays the same. So we are keeping the other guy, which means my second bracket will have a minus. Do we remember this, guys? Thumbs up, thumbs down if you remember, whether you understand, rather, whether you understand this. A positive is telling you to keep the other guy. Because anything multiplied by a positive remains the same. A positive, if you multiply it with another positive, it doesn't change. And then if you multiply a positive with negative, the negative doesn't change. So it means keep. Don't forget that, guys. If you forget that method, just remember whatever you multiply here has to give you the sign that's second there. So if you put two positives there, that means you're going to have a positive times a positive, which would have been incorrect. Okay, guys, there are many ways to check. Okay, factors of 12 that add up to 4. Okay, factors of 12. 1 and 12, 2 and 6, 3 and 4. Is that all? Yes, it is. Which of my factors are going to give me a positive 4? Will 1 and 12 ever give me a positive 4 no matter what I do with it? No, but 2 and 6 will. Okay, now the middle term is a positive 4. So will my 2 be positive or will my 6 be positive? Your 6 will be positive. Nice, guys. So it's 6 and a 2. Are we finally done with this question? Yes, we are. There's nothing else we can do, right? There's nothing else we can do. If you check all three brackets, there's no common factor. There is no difference of two squares. There's nothing else we can do. And do not start multiplying these brackets out, guys. Oh my goodness. Remember, the word factorize means put it in brackets. Okay. Expand means get rid of the brackets. So do not start multiplying. Yes. Yes, brilliant. Exactly. And then you're going to lose all your marks because you just undid all your hard work. Imagine going through all of this and getting nothing because you just did the right thing, but then you reversed and you undid it. That would make me cry. I don't know about y'all. Okay, mark allocation. First one is for this common factor here in the bracket. Okay. Then you're going to get 1 for taking out the common bracket. Okay. And then you're going to get 1, 2, 4, your final answer. That is factorized. Okay. I know, brilliant. I see that so often. So when you see the word factorize, just know that as soon as you have your brackets, leave it. But when you see the words expand, that means wherever you see brackets, get rid of them. So they're opposites of one another. Okay, can we get a thumbs up, thumbs down, a final one on this question? Beautiful. Do you guys want to go get a glass of water? I am giving you 4 minutes. Okay, now it's 3. It's fine. I'll give you 4 minutes. 15:26, please be back. Okay. 15:26, be back. Umar wants to play a cruise. I didn't plan a cruise for today, guys. I didn't plan a cruise. Okay, but we can. Who has a category for the cruise? Does anybody have a category for the cruise? Okay, while you guys get that sorted, the rest of you can go drink water. These are some exam tips that we are sharing, and then we'll play one round of cruise. Okay, the first thing is please get enough rest between studying and before the exams. It doesn't help to stay up the whole night and day, guys, because you're trying to study. Then you get to the test and you're too tired anyway and your brain doesn't work. You're going to end up crying and upset. Okay, my second tip is go through the whole exam. It's strange to me because we give our learners reading time, but they don't read. So go through all your questions from question 1 right to the end. decide what you're going to start with and start with the ones that you're most confident in. Because the more your confidence grows, the better you're going to do anyway. Okay. Number 3, please ask for help if you need it. If you are studying and you realize, I actually have no clue what's going on in this chapter, go to your teacher and ask. Ask me at the end of the lesson. Get help. Okay. And it goes along with number 4. Study according to your strength in each topic. You cannot allocate 2 hours for every single chapter when you know, let's say, 4 chapters like the back of your hand. Rather give more time to the ones that you are really struggling with. Please be smart about how you use your time, and then pace yourself during the exams. Oh my goodness. A 5-mark question cannot spend 15 minutes of your time. It cannot, guys. You need to pace yourself, okay? If the question, let's say it's out of 70 and it's a 60-minute paper, then by the time you are 30 minutes through, you must be done with 35 of those marks. Okay, if you're still going on mark 20 and half the time is gone, you know you are in trouble. Are we with me, guys? Please. And remember, everything in that paper is something you have done before. Don't panic yourself and say, oh my goodness, I have no clue what this is. Oh my gosh, I want to die. Don't do that. It's always stuff you've seen before. You've seen with the ones we've done before. You have done difference of two squares. You've done common factor. It might look hectic, but it's always something you have seen before. Okay, are we happy, guys? Please remember these. Please remember them. Okay, let's hear cruise. Umar has a category. Umar, take it away. Umar's going on a cruise and bringing a house, guys, an entire house. Can I bring a car? No, of course I'm staying. Guys, I don't think Umar ever wants me to go on a cruise. What are you guys bringing? We have a house. A car can come. Okay. A hotel is going, apparently. Okay. Key is staying. Can I please bring electricity? Nope. Is a building going? Nope. Hot chocolate? Nope. A house and a hotel. Can I bring a school? I can bring a school. I can bring a school. Apartment? Yes. Apartment. Hockey ball is staying. Skyscraper is going. Umar, are these just buildings? No. Can I bring a hospital? No. Hairdryer? Guys, I can't tell what these have in common. Does anybody want to try? I'm obviously terrible at this. I didn't even spell skyscraper. Yo, guys, this is recorded and you let your teacher just. I'm gonna throw the whole recording away. You guys will be strong. I'm sorry. Is it tall buildings? No. Buildings with 3. You guys have houses that are 3 stories. You're living a nice life. You guys are living a nice life. Guys, what do all these things have in common? I can't decide. They all have doors. Is that it? A hippo. Huh? I shame. Enter says, is it every second person that answers? No. Close. Every third person that answers? I know, Entle. Oh, it was every third person. Guys, we would have never gotten this. What? Well done, guys. Well done. You? I mean, I really didn't want me to go. Oh, but I ended up going. Yeah, you see, having a big mouth helps sometimes. Must ask over and over again. Yeah. Okay. Let us go back. These are exam tips, guys, that we discussed. You can take a screenshot. Just remember them. Okay? Please remember them. Alrighty. Now we are off to exponents and we're choosing between A, B, C, D, E, and F. Okay, no, F we're gonna do. Wait, F we're gonna do. See, Umar, I'm on your side this time. F we're definitely gonna do. So let's choose between A, B, C, D, and E. There's A, we have B, we have C, we have D, and we have E. Again, E and D, C and B, and A. Okay, D seems to be winning so far. 1, 2, 3. Come, guys. Only how many people? 1, 2, 3, 4, 5, 6 people. We're even getting less and less, the people who are responding. Thank you, Avro. Okay, it seems D is going to win, so we're doing D and E. Let's look at D. Let's take a look at D. Okay, which laws of exponents look like you're going to be using them? See, this is what I mean by stuff you have done. As soon as you see this, you see a multiplication. So you know you're going to apply law number 1 at some point. You see what I mean? So you must unpack your thoughts. There we go. We have a distribution one, which is going to go with power to a power. Okay. Do you see the difference of when do you distribute the exponents? This time, there's no plus or minus between the terms. I know you guys are going to say, but there's a negative there. That minus is not separating anything. Do you guys agree with me? Do we agree? Or do we understand what I mean? The plus or minus that I was talking about. Okay, let me show you the difference. Okay, this plus is separating x and 2. Okay, this negative is not separating anyone. It's telling you that 2 is negative. That's the difference. So in scenario A, this one, you cannot distribute. But in scenario B, this one, you can distribute. Thumbs up, thumbs down on what I'm saying. Am I making sense? Wonderful. Okay, let's get working. So we can distribute the exponents. So let's distribute. So my negative 2 is going to get a squared. My x gets a squared. And my y squared gets a squared. Then everything else, you just rewrite it the way you know. There we go. Okay, let's simplify this. What's negative 2 all squared? There we go. It is a positive 4. Then I have an x squared. Okay, now here's Umar's power to a power. What do we do with those exponents? Yes, it's y to the power of 4 because we multiplied them, not because we added them. Guys, I hate using 2 because 2 confuses people. Do you agree that if we added them, we would have gotten the same answer as if we multiplied them? So we multiplied them. We didn't add them. Okay, guys. Great. And then we have times and my second bracket. Okay, Now we're multiplying. We can use our symbol, numbers, and variable. Okay, let's start with symbols. I'm multiplying a positive number with a negative number. What's my answer going to be? I'm multiplying a positive with a negative. There we go. Minus, and then what is 4 times 3? So we've done symbol, we're on number. 4 times 3. Come, guys. A 12. And because we're multiplying, which law of exponents are we going to be dealing with here? We are multiplying and we have same bases, which is law 1. And law 1 says, what do we do with the exponents if we're multiplying things with the same base? We add them. So it's x is going to be to the power of this 2 plus this 2, which means it's x to the power of 4. And y is going to be to the power of this 4 plus negative 2. What happens with that plus minus? That's what it looks like, right? Yes, it becomes a minus 2. So then y has an exponent of 2. Okay, let's do mark allocation quickly. First mark for distributing this guy. And your second mark could be either for the sign in front and answer, or one for the number as well as the variables. Okay, can we get a thumbs up, thumbs down on D? We only have 25 minutes, guys. Time flies when you understand what's happening in maths. Can we get a thumbs up, thumbs down? Beautiful. I know, right? If this was a normal lesson, we would have ended the lesson like 5-10 minutes ago. Fast. Okay, let's see if. Okay. Now, with if, you have two options. You can either first multiply what's under the cube root, or you can split that cube root up. And again, the only reason I can split the cube root up is because of multiplication. If this was addition or subtraction, would I be able to split my cube root up? Would I be able to split it up? No. Are you with me? Now, what do I mean by split it up? This is what I mean. You can say this is the same as whatever the cube root of 8x cubed is times whatever the cube root of 27x cubed times the cube root of negative x to the power of negative 9. Do you see what I mean by split it up, guys? Isn't this easier if you don't have a calculator? It's easier than saying 8 times 27 and then trying to cube root it. It will probably be a huge number. Are you with me, guys? So as soon as you have a times or divide under your square root or cube root, you can split the terms up. Okay, so let's work it. Great. Let's start with the cube root of 8x cubed. Okay, cube root of 8, let's start with the number. Cube root of 8 is 2. And the cube root of x cubed is just x. Is there anyone who's confused about why it's x? No? Okay. Okay, move on to the next one then. The cube root of 27. Cube root of 27 is 3. And then again, the cube root of x cubed is just x. Great. Move on to the next one. Now, we have a cube root of a negative number. And if we were cube rooting a negative number, will my answer be negative or positive? There we go. Negative. Okay, negative x to the power of, thank you very much, Umar, negative 9. Is there anybody, negative 3, sorry. Oof. I say thank you and then I write the wrong thing. Ha! Is anyone confused about where that negative 3 comes from? Anybody? Please don't be shy, guys. Okay, maybe I should do that. Thumbs up, thumbs down on the -3. If you understand where it comes from, just give me a thumbs up. If you don't, give me a thumbs down. Brilliant. Was that a thumbs down or was that a mistake? Does that mean no? Let me know in the chat. Let me know in the chat, brilliant, if you're confused, okay? Okay, now multiplying, this will be so much easier. We're multiplying a, it's a thumbs down, so you don't understand. Okay, when you're rooting variables, you divide the exponent by whatever's on the outside. So if I have the square root of, let's say, x to the power of 12. In a square root, brilliant, what number would be on the outside here? We don't write it, but what number would be on the outside there in a square root? A 2. Beautiful. So when you're square rooting, you say whatever the exponent is divided by the number that would have been on the outside, which is a 2, and that gives you x to the power of 6. So if you look at our example here, we knew it was going to be negative, and my exponent was a 9. This time, what's outside my root is a 3. So divided by 3, and this will give you negative x to the exponent of -3. You feel better? Hopefully, hopefully. Okay, this is a very important skill to have. Otherwise, you're stuck. If you can't do this, you would have been stuck in this question. So, okay, you're very welcome. Okay, now we're multiplying. We're multiplying a positive by another positive by a negative. What's my answer going to be? Positive, positive, negative. What's my answer going to be? There we go. It's a negative. Okay, and then numbers, 2 times 3. There we go. And let's look at variables. First law, we're multiplying, so we're adding exponents. It's going to be x to the power of 1 plus 1 plus -3. What does this positive negative do? It becomes a negative. Okay, so let's see what's happening here. 1 plus 1, how much is that? -3. So 2 minus 3, so it's x to the power of -1. Now I don't like this and I want positive exponents. Remind me again, how do we do that? We actually spoke about it in the last lesson. It was definition 2. Definition 1 was anything to the power of 0. Definition 2 was talking about negative exponents. And what did we say we do with those exponents? If I want it to be positive. Anybody remember? It goes to the denominator. Yes, so then you have -6 over x. Can we get a thumbs up, thumbs down on that answer? I know you guys might be confused about that negative exponent thing, but we have done it before. Are we good? Okay, let's look at our mark allocation for this one. Okay, so you're going to get a mark for square rooting them successfully. Then you need to get a mark for the adding and subtracting thing. You're going to get a mark for the preliminary answer, but your final mark is for taking your x to the denominator. Okay. Wonderful. Let's look what we have here. Question. How many questions do we have left? Okay, just 2. 5 and 6. Okay, let's look at question 5. There's A. We have B. We have C. And we have D. There's D. Okay, so let's get voting. D, O, A. There's A, sorry. A, B, C, D. Woo! I don't know my alphabets, guys. Yo! That went south very fast. Okay, we have how many A's? 1, 2, and then we have 1, 2, 3D, 4D, and 1C. Whew, there's a lot going on. I think D is winning. D seems to be winning. One last chance for people who haven't voted to vote. One last chance. 1, 2, 3, 4. 1, 2. Umar wins C as well. Brilliant is picking D. Okay, it seems like D won. Okay, now this is the tricky part. We spoke about expand and factorize. What does the word simplify mean? We've spoken about expanding, which means get rid of the brackets. We spoke about factorize, which means put brackets. What does simplify mean? Umar says multiply. You're sort of there, Umar, sort of. Simplify means do whatever you need to do to fix this. Okay, so in other cases, you might have to expand, right? You might have to times it out. But in this case, in order to simplify it, we have to do what? Solve is a whole nother different one. Okay, solve means I need an answer. It means I need x equals. And in this case, we can't do that because these are expressions and not equations. Yes, in this case, we have to factorize. Do you see what I mean? That's why simplify is the trickiest instruction, because it's basically saying, look, you do whatever you have to do to fix this and make it as simple as possible. Okay, guys? So when you're doing simplify, now you have to think of everything. When you're doing simplify, you have to think of factorizing, but you also have to think of foiling and multiplying out. You have to think of like terms. You have to think of fractions. Do whatever you need to do to simplify this. Okay, let's look. In this case, we have to factorize. Okay, because look at these. These three are trinomials, and this is difference of two squares. Let's start with my numerator. I have a trinomial. What's my first factor going to be in my two brackets? There we go, x and x. My sign in my first bracket, remember the first bracket takes on the sign that's in front, right? Minus. Does that minus say we are keeping or we are changing the second guy? Change, which means my second bracket has a what? There we go, guys. It has a plus. Are we with me? Now, what factors of 15 are going to give us 2? Let's see. 1, 15, 3, 5. Okay, it doesn't have that many factors. Which of those two are going to give me a middle term of 2? 3 and 5. And since I want a negative 2, will my 3 be negative or will my 2 be negative? My 5, sorry. Okay, if I make my 3 negative, I'm going to have negative 3 plus 5. Do you guys see that? Which is going to give me positive 2. Do we want a positive 2? No. So your 5 has to be negative and my 3 has to be positive. Great. We've dealt with that numerator. Let us look at the denominator. Difference of two squares. Tell me what my two brackets are going to be. Difference of two squares. What are my two brackets going to be? My brackets, guys, my entire brackets, there will be an x and an x, but I want you guys to fully factorize it on your own. What does it give me? Come, guys, I know you know. It's a x plus 3 and a x minus 3. Okay, times. Now we have another trinomial. So there are my two brackets. First one is x and x. What's my symbol in the first bracket? A minus. Does that mean we are keeping or we are changing the second guy? Does the minus mean we're keeping or changing the second one? Change. There we go. So my second bracket will have a. We're changing the second one. We're changing this one, guys. So if I'm changing it, then it's going to be a what? A negative. There we go. Okay. Factors of 12. 1, 12, 3, 4, 6, 2. Which of my factors are going to give me a negative 7? There we go. 3 and 4. This time it doesn't matter where you place them because they're both negative anyway. Okay. Okay, and then we put our line. Ew, why is it highlighter? There we go. Okay, finally, again, another trinomial. Again, x and x. What are my two signs in the brackets? This time I'm going to let you guys tell me the signs. What are my two signs? There we go. A negative and a positive. Great. Factors of 12 again. This time they need to give me negative 1. Which of these are going to give me negative 1? If there's nothing in front of the x, this is negative 1. Right? So which two factors can give me negative 1? Is 1 and 12 ever going to give me a negative 1? Hello? No. Is 3 and 4 ever going to give me negative 1? Yes, it is. Now, which one must be negative? Will the 3 be negative or does the 4 have to be negative? There we go. Negative 4 plus 3. Whew, we factorize. Now what, guys? Now we can cancel. Let's start with the fractions themselves. I have an x plus 3 in my numerator, x plus 3 in the denominator. They can cancel each other out. Happy. I have an x minus 4 in my denominator, x minus 4 in the numerator. They can cancel each other out. After I cancel, I like rewriting it with what's left. What's left if I multiply the numerators here? It will be a x minus 5 times x minus 3 in the numerator over x minus 3, x plus 3. Okay, can we cancel out further? Yes. Which one can we cancel? There we go. X minus 3 and x minus 3. What's left? It's x minus 5 divided by x minus 3. Can we cancel out further? No. So that is your answer. You cannot cancel when it's more than one term. This minus and plus here are a problem. So you can't cancel out any further. Okay, so we could cancel the brackets, guys, because they were being multiplied. Do you agree? It was the whole entire brackets that we were canceling. But you cannot cancel when there's a plus or minus in between. Okay. Can we get a thumbs up, thumbs down on this one as I put down my mark allocations? I am. That's why I'm here. Okay, so factorizing both of these is definitely a mark each. Okay, and then canceling the first time and your last answer. So that's 5 marks, guys. 5 marks. If your paper's out of 50, you have earned 10%. Isn't that amazing, guys? Okay, we have our last one. A, this is the age stuff. B, 3 children and money. And C, consecutive numbers. The age stuff, the consecutive number stuff, or money stuff. A, B, or C. This is A, age stuff. That's all you, Umar. Age, or B, money stuff, or C, consecutive number stuff. Well, people aren't voting, so I'm just going to take. Okay, now it's complicated. Okay, so for A, we have 1, 2, 3, 4. Okay, for C, we have only 1. And for B, we have 1, 2. Okay, I'm sorry, Brilliant. It seems the age stuff won. Okay, a mother is 3 times as old as her daughter. 6 years ago, mother was 6 times as old as her daughter. How old are they now? Okay, so firstly, we're working with mom and we're working with the girl. So we're working with 2 people, right? And we're also working with 2 time periods. We're working with right now and we're working with 6 years ago. Okay, now the first thing says a mother is 3 times as old as her daughter. So that's now. Do you guys agree? That is present tense. Okay, so currently, do we know the daughter's age? No. So what do we call it? If we don't know the daughter's age, we call it X. And if daughter is X, and they've told us that mom is 3 times as old, then what's mom's age? 3x. 3x. Okay. Do you understand, Kenneth, how we got 3x? Don't use different variables or it's going to confuse you. Okay. Wonderful. Now, if I ask you, how old were you 5 years ago? What would you do with your age? What would you do with your age? Yes, Entle and Shady, you would minus 5, right? If I say 5 years ago, how old would you? You would just minus 5. So the same thing. If mom is 3x now, that means 6 years ago she was whatever 3x is minus 6. And if the girl is x now, that means she would be x minus 6 6 years ago. Does this make sense so far, guys? Thumbs up, thumbs down. It's just a logical thing, right? 6 years ago, they were whatever they are now minus 6. Okay, now we look at the rest of the information. During this time period, 6 years ago, the mom's age was 6 times daughter's age. What does that mean? Mom's age, which was 3x minus 6, was 6 times daughter's age, which is x minus 6. Does that make sense to you guys? Thumbs up, thumbs down? So in the time period of 6 years ago, whatever mom's age was, which is 3x minus 6, was equal to 6 times whatever daughter's age was, which was x minus 6. Okay, and once you get here, it is so easy because you solve for x. So we have to distribute here. I'm going to go quickly and do it on my own because of the time. So you have 3x minus 6 equals 6x minus 36. I'm going to bring my 6x that way and my 6 that way. Excuse me, which is going to give me 3x minus 6x is equal to negative 36 plus 6. Then we have negative 3x is equal to negative 30. Divide by negative 3, divide by negative 3. That means x is 10. And we started off by saying the girl's age is 10. Is x, excuse me. That means currently my girl is 10 years old and my mom is 30.